Welcome back to Patch Channels. We'd like to continue with our implementation of the linked list. In the previous video, we implemented the add function where we saw the rules. Rule number 1, that our list should have no duplicates, and rule number 2, all elements we add should be sorted. We are still on the singly linked list of a single threaded environment, and from there we'll be moving on to the concurrent linked list as the book details on page 198. Alright, so in this video we'll be implementing the remove and contains function. So the contains function simply checks whether a given element is in the list, and let's say it will take an immutable reference to self and the key of the element that we are trying to check. Alright, so we shall say that we shall keep a current node to the current node that we are looking at, and we shall write a while loop which is going to be a while let car, and we should say that if the node that we are looking at has the key equaling to the key that we had last time, here we can return true. Otherwise, we can check if the node has a next node. Then current node should be equal to node.next. Otherwise, we shall break the loop. And once we are out of the loop, we can simply return false. We couldn't find the element in the list. Okay, looks like we have a spelling error. This is supposed to be current node. Okay, let's write a simple test function for this contains to check whether it works as expected. So here we shall add another test. Let's call it test contains. Now the previous one, I think we can follow the add function where we create an empty list and then add a few nodes and then check that all of them are there. So for I in 0 to 100, I think 100 is reasonable enough. If I and 1 is equal to 1, let's see if it's odd, then list.add. We don't need to assert in this case because we already added this and tested it in test add function. And let's also add even numbers. If I and 0, 1 is equal to 0, then add I. Okay, at some point I think we should also test whether the order is maintained. For this, at this moment we're just assuming. Okay. And now we should assert that list.contains I returns true. All right, let's test. Okay. All right, so the contains function seems to be working fine. now let's implement the remove function. Now, according to our book, the remove function will also take a key, check if the key is in the list. If it's there, then we can simply remove that node from the list. Otherwise, we shall just return false. Okay, so this is going to be I32, which should return Boolean, because as we did in the add function, we should say while at some node equals current node, then if node.key is equal to key. Let's skip this for now. We shall come back later. Now, if on the other hand, if node.next is sum, then if node.key, let's get next. You can say let next equal to node.next dot as mute. Mute unwrap, and if next dot node, if next dot key is equal to the key we are looking for, then node dot next is equal to next dot take, and here we can simply return true. Otherwise, we shall say that if this is not true, then we can just move on to the next node. So we shall say that otherwise, that's not something I would like to do. Else, we can say that our node is equal to next, and we can continue. If we don't have a next node, then we can say that, alright, I think this was supposed to be mute. Okay, so if we don't have a next node, we should return false. We've gone through the whole list and we didn't find the key, so in that case we should just return false, and here we should simply break. So once we break, in this case here, that means our head is the next node. I think, let's say, in fact, I think we can just come here and say that our head has the key that we are looking for, therefore it should be deleted. And therefore, we simply have to say that next self.head is equal to node.next.take, and we shall return true. Now, if we don't have a head, we shall jump right here and we'll be required to return false. Okay, so it's time to test our remove function. Does it work? I think we should test a few more corner cases compared to the previous functions. So let's add a new test. Let's call it test remove. And again, we shall create an empty list. Now let's assert that when you try to remove anything from this empty list, you should get false. That this is equal to false. let's also add something. List.add 0, and we should be able to remove 0 from the list. That will be list.remove 0, and it should leave the list empty. So assert list.contains it should be empty anyway. I think there should be a way of testing if it's empty. We can add a function later for that, because this doesn't really guarantee that it's empty. But since we have only added 0, we can just assume that it's indeed empty. Okay, now let's add a few more elements. List.add 0. Let's add 1. Now we have 2 nodes. Let's remove list.remove 1. Let's remove the tail, and this should also work. So we should assert that list.remove tail works, and we should also assert that now 0 is still there. 0 is still there, but 1 is gone. Okay. Now let's add 1 again, and let's add 2. So now we can test removing a list from the middle. In other words, list.remove 1 should return true, and we should also confirm that everything else is still there. So list.contains 0 should return true. List.contains 1 should return false. But list.contains 2 should also return 2. Okay, and in this case, let us add a bunch of numbers. Okay, now let's remove only even numbers. Then we should first of all, this should work since we added them. It should be able to remove them. These are odd numbers. I think we need even numbers. Okay, this requires, this is an assertion, it's a macro. Okay, and after removing these, we should test for I in, now the odd numbers should still be there. I just like writing in hex. What's wrong with that? I don't see what's wrong. Anyway, we should assert that the odd numbers are still there. And the even numbers must be gone. Okay. And this is supposed to be equals All right, now let's test our remove function. All right, the remove function works, and this should make it for our single linked list for a single threaded environment. And in our next video, we will look at concurrency in Rust before we can move on to one of our concurrent linked lists in the book. Thank you for watching. If you like this video, please like and subscribe. Bye-bye.